3.7, evaluate determinants and apply Cramers rule. So at least we'll do determinants today. Might wait on Cramers rule till Monday. If we do it all today, then Monday will be a work day. So we're taking the determinant of a 2x2 matrix. And so if we do that, the determinant of matrix, if you already did your notes, you already have this, but just to refresh. A, B, C, D, then to find the determinant, we multiply A times D minus B times C, and then that number, whatever that comes out to be, is our determinant of the matrix. If you have a 3x3, which is the biggest that I require you to do by hand, so A, B, C, D, E, F, G, H, I, then what we do is we have A times the determinant of the 2x2, the 4 terms. So we would do A times whatever the determinant of, like, basically the little matrix here is. So this would be A times EI minus FH, then minus B minus B times, we basically cover up everything else in that column, so we're taking the determinant of these things that I've boxed in red, so times DI minus FG, and then plus, so what you're going to notice is these signs alternate. The only exception to that is it still follows that pattern, but if a number up here is negative or positive, whatever, it might change the sign on it potentially. And then the last one is C times the determinant of that, which would be DH minus EG. So that's the easiest way to do it. The book gives you this other diagonal way that might have been in your notes. Maybe it wasn't. I don't know. I don't usually teach it because it's way harder, and I've only ever had one student like it. So, anyways, so let's jump into some problems. And I will try to color code this for you, so if you like to use colors, then it's a good time for it. So evaluate the determinant of the matrix. So something like 4, we've got the matrix 7, 1, 0, 3. So it's this diagonal, so 7 times 3, so that's going to be 21, minus this diagonal is 0, so that's equal to 21. Six, you have the matrix 1, negative 3, 2, and 6. So we've got this diagonal here, so 1 times 6, we've got 6, minus negative 3 times 2, so that's negative 6. This is going to become plus 6, is equal to 12. All right, this one I want you to try on your own, or like at least tell me what to do. Negative 5, 12, 4, and 6. Yeah, negative 5 times 6, which is?
Negative 30.
Negative 30, and now what?
12 times 4.
So plus 48?
Minus.
Minus, yep. So then this is negative 78. All right, we feel okay with the 2 by 2s? All right, 3 by 3s. So we've got 12, which is 1, 2, 3, 5, negative 8, 1, 2, 4, 3. All right, I'm going to do it below just so I make sure I have enough room. So basically, the top row is only used to tell us what we're multiplying by. Okay, so it's going to be 1 times, and essentially what happens is we cover up everything else in that column and we take the determinant of the other stuff. So this is going to be 1 times the determinant of this 2 by 2. So 1 times, so what would the determinant of this be? Or like, how do I get it?
Negative 24 plus 4. Negative 20.
Minus 4.
Oh.
Okay, so that's that part. I'll simplify it down later. So then now, 2 times, or well, minus 2, because we changed the sign. So it starts out, it's always positive, negative, positive. If you were to have a 4 by 4, 5 by 5, whatever, it just keeps alternating, the one across the top. So negative 2 times the determinant of these that I have boxed in red. So what would the determinant of that be?
Still be 9.
Huh?
It would be 15 minus 2.
Yeah, 15 minus 2. You're just basically ignoring this and making the box out of the other stuff. So your 2 by 2 is 5, 1, 2, 3, basically for that one. Yes.
Why would you switch it from positive, negative, positive, negative?
It's just the pattern that it follows. I don't really know why or who decided that that was the pattern, but for some reason it is. I'm sure there's a reason, I just don't know it. I took a class like that was like in college entirely about matrices, and they didn't explain it. So, I don't know. And then the last one is plus 3 times the determinant of this 2 by 2, which would be what?
20 and then minus 16. Plus 16.
Yeah, plus because it's minus and negative, so plus 16. Because this is negative 16, but the formula is minus that diagonal, so it becomes plus, negative, negative. So over here, this is going to be negative 28. This is 13 times negative 2, so negative 26. And then 36 times 3 is, somebody know that off the top of their head? Let me have to think about it.
Okay, 60 plus 16, or wait.
36.
Guess that's one way to do it.
It's 36.
48. 48. 60 plus 48. Wait.
Is it 118
I think it's 108.
or 10? Okay. I'm really, like, honestly, since I started using a calculator, like, in college, I'm, like, so bad at quick math now. So then this ends up being, yikes, what's that, 54, negative 54, so that ends up being 54.
I'm not racing.
Huh?
I do need to get a win.
Tiebreaker today.
Oh, I didn't know what that was for.
You ever go take that?
Yeah, but that tape won't hold it.
Yeah, we realized it was just kind of temporary.
Need to figure out a better solution for basketball season to not have to put it up every time.
Just make it out of wood and then like nail it to the wall.
Honestly, it's an option.
I That would actually be really cool.
And then we could just like,
I'll do that for my
and then we could have the ball be like, have
I'd sign it.
We could put like hooks and have like the ball put in there, and then we can like take it off for each season. Like,
I'd sign it. All right,
Woodworking class.
another one.
I don't know what would be possible.
-7, 4,
So much fun.
5, 1, 2, -4, -10, 1, and 6.
Like drama.
You know who could actually teach it here?
Woodworking?
Yeah.
Dad.
Huh?
Who?
Mr. Keller, the bus driver.
Oh yeah, he does.
He's so good. He's gonna make some stuff for our new
He
house.
made that desk in the lunch room. He made the table. for-
Pretty much anything wooden you see around the school, he's made.
That's
We need to ask
He's
That-
super good at
cool.
it.
Thing that the VHS thing.
We need someone to
Yeah,
do all that.
and the boxes.
Really? I was just joking.
No, yeah, like for real, he makes these.
That's actually-
Like not like the bookshelf over there, obviously. Some teachers have a bookshelf that he's made or something like that, but
That one too.
these ones he made, like these were like his initial ones, and they were like weren't quite the right size for what they needed, and I was like, well, they work for me, so like I'll take these ones because I had different stuff than a lot of the other teachers, so he put those ones up for me. But all right, this one got -7 times the determinant of this. And so, just to be clear, because some people get confused, just because this started out as negative doesn't mean the next term becomes positive. It always follows the positive, negative, positive. If the number happens to be negative, that's fine. It's going to change the sign, but it's still following that pattern. So 7 times determinant of this,
Would be Nate.
12 plus 4. Then minus 4 times the determinant of the outer 2,
6 plus 4.
not plus, minus.
Oh, because of the answer.
Wait.
So
So, regardless is positive or negative, but if you start with a negative, you just keep it negative.
yeah, because it's basically like in, how do I explain it? Like, say the quadratic formula, something you're more familiar with. So it's like negative b plus or minus, blah, blah, blah. Well, if b is negative, then that term becomes positive when you put it in the quadratic formula. But you don't change the formula because the number was different. So, yeah. So it always follows, like this will always be positive, this will always be negative, this will always be positive. If the number happens to make it something different, that doesn't matter.
Yeah.
That's fine, but we have to keep that pattern all the way across, or your answer will end up being wrong.
Oh gosh.
So then plus 5 times the determinant of this. So then we've got -7 times 16. Oh gosh. -112. -112. -4 times, or -4 times -36, that's going to be plus 144.
Wait, that's 30.
Yeah, it's supposed to be
30, -34.
34.
Oh, thanks. Yeah, that would have, oh, wait, that would have
So
definitely,
136.
cool.
Plus 136.
Oh, wrong color. Then 5 times 21 is, what is that, 105? So then 129. All right, I would like you to try this next one by yourself, and then I'm going to show you how to check them on a calculator. But this one, try on your own paper first, and then we'll go over it, and then we'll check and see if you're right based on the calculator. All right, -4, 3, -9, 12, 6, whoa, that was way too far over. 0, 8, -12, 0. So when you're done, go ahead and put that into matrix A as a 3x3 matrix, and then I'll show you what to do from there. What did y'all get by hand?
There you go. That's the one you
Yes.
told me. Negative.
I got.
You got one.
Emma, did you get the same thing?
I'm still doing it.
Oh, okay.
What's the answer?
We're going to find out in the calculator.
Oh.
All right, so did you type the matrix in?
Yes.
Yes.
Emma's like, I'm working on it.
I'm slow.
I'm gonna let her get it first, and then we'll do it. So a lot of times the way these problems work is I'll tell you that you need to basically show the work for the determinant, but then I will also say something like, as a part 2 of the problem, check it on your calculator. And so when we do that, you would write something like DET of matrix A, and then show me what that number comes out to be. So hit second matrix, and then arrow over to math, and it's the first option, this DET. Hit enter, and then type in your matrix A, and then just hit enter. And 1728 is the answer. Boom.
Boom.
So, in college, I was in a calculus class, and we were doing these. And my teacher decided that we needed to find the determinant of a 4x4 matrix. And it kind of works the same way. So you take the top one, and then you do the determinant of the 3x3 matrix. Which means then you have to do this. And you have to do that for 4 times all the way across the board. It took me like 30 minutes, and I still didn't finish the problem. And there was a 5-question test, and that was one of them in a 50-minute class. Afterwards, he was like, this might have been a little long. And I was like, you think? Because we couldn't use a calculator. I was like, I know how to do it. So I like showed that I knew how to do the process. He like gave me credit for it. I just didn't have time to finish it. I was like, I don't care how fast you are. Like, you are not going to finish that. My dad at one point had to do a 13 by 13.
What?
Yeah. So his like classmates came in and had this like huge, it was like for a computer programming class. They had this like 25-page document of like working on it, and they still weren't getting the right answer, and we're still having problems, whatever. So my dad went up to the professor and he was like, I know how to write a program to solve this. Can I do that? And the teacher was like, I don't care. So he goes home, he writes a program. He comes in with like 2 pages of information and has the right answer. And the teacher was like, wow, you got it. And he was like, I know. I've already done this before. He was like, we did this in a different class. And all of his classmates were like, how do you only have 2 pages? He's like, because I wrote a program to do it. So, anyways, all that to say, anything bigger than a 3 by 3, should I ask you to do that, you use your calculator for. Sometimes I will say use your calculator only to find the determinant. Just depends. So, anyways.
Okay, so it's
How
super
you-
easy to do it on the calculator.
Yes. So I would say anytime you're not sure if you did it right, check it.
13 by 15.
This is a test where I typically give you a non-calculator portion and a calculator portion of the test. So, anyways. Or I say if I don't see work, then I automatically mark it wrong if it's on the non-calculator part.
I think I did something wrong.
For what?
I have 2 shifts in my calculator. I'm not sure it's not very one.
Huh?
Like, I have like a shift for like yellow and I have a shift for
Alright,
like
which mean you do
green.
Oh, yeah, we're gonna
But I can't remember
after
which
you finish the problem.
Should just be second and then the number.
And there goes my
I did,
nice
like-
All right, wait, I'm not done yet. We have 2 more problems, and then we're saving Cramers roll for Monday.
Dos más.
All right, the next ones say to find the area of the triangle with the given vertices. And as you might guess, we're doing it with matrices. So we've got number 22. We have the points. A is 1, 5, D is 4, 6, and C is 7, 3. And so normally when we take the area of a triangle, it's 1/2 base times height. So this formula, which I think should have been in your notes, is the plus or minus. Okay, so in front of it, it's going to be area is equal to plus or minus 1/2 times the determinant of, it'll be x1, y1, 1, x2, y2, 2, or 1, and then x3, y3, 1. So the last column is all going to be 1s. We're making a 3 by 3 matrix out of the points. I'm getting ready to write it and explain. The plus or minus indicates the appropriate sign that should be chosen to yield a positive value. So if you have the wrong one chosen, then just make your answer positive at the end, because your answer has to be positive for area, basically. The ones that we're going to do need to be negative, because otherwise it'll come out to be a negative answer. So negative 1/2 times the determinant, and we just do the numbers across. So 1, 5, 1. The last column's always going to be 1s. 4, 6, 1, and 7, 3, 1. So I will let you do these on your calculator. So type in this matrix to your calculator. So then once you do that, you're going to take the determinant of that and then multiply it by negative 1/2. If your answer comes out to be negative, then it should have been multiplied by positive 1/2. So What'd you get?
You said it should be negative, right?
Oh, the determination.
It should not be negative. It needs to be positive because it's area.
The determinant?
No. When you multiply it by 1/2, you either multiply it by positive 1/2 or negative 1/2, depending on what your determinant is. So in this case, your determinant should have come out to be negative.
Oh my goodness.
So if your determinant came out negative, we're multiplying by negative 1/2, and whatever that number is the answer. That's the area.
Wait,
I'm so
I got negative
confused.
12 for my determinant.
Yes.
So I should
Now take half of that, but negative half, so it's going to become positive.
6.
I don't think I did this right.
6.
60. Okay, that's actually kind of cool.
Did you type it in?
Yes.
Did you take the determinant?
No. That's what I did. I didn't. I'm sorry.
Oh, you get started.
Shut up.
So the area is that. Now, when you do it, when you want to find the determinant, you can go ahead if you want, and you can, when you type it in your calculator, you can do 0.5 or negative 0.5 depending times the determinant of matrix A when you type it in, and then you don't have to do an extra step. It'll do it all in one if you just wanted to. Obviously, in this case, it was negative because of the determinant, but you won't know if this is going to be positive or negative, aside from the fact that I just told you, until you actually find the determinant.
I just got
Oh my.
All right, try 24 by yourself, and then we'll be done.
Wait, you should go back up real quick. So, 5, 4, 6, 1. Okay,
So yeah, so basically it's whatever the coordinate is, and then 1 is in the last column. So your last column should all be 1s. So A is 5, negative 4. B is 6, 3. And C is 8, negative 1.
We always multiply that by 1/2.
Yep. And if it comes out that the answer is negative, then just make it positive. Basically the easiest thing to do.
Just change my English to Spanish. What are you doing?
Didn't even know that was possible.
Oh no.
Makes me already proud. I think I got the right answer.
I hope I do.
Mine's very looking
Check
suspicious.
clock. That's not right. It's not 12 2
What do we get?
Or it's not 12.
Negative
It's
2
not
point.
that wide.
I don't
2,
have
5.
a set clock.
No.
I got
Yeah.
9.
It's 9.
Yes. How did I? What did
I got 9.
Wait, what
I
was
don't
it?
know. You just had to type it into a matrix and then find
What
the
are you doing?
determinant.
I? Huh?
What are you doing?
I don't know. Something wrong.
You're doing something stupid. So it's this. You just type in your matrix,
Yes.
and then you take your detriment of it, and then you multiply it by 2 and make it, or divide it by 2 and make it. It's easy. This is the easiest thing we've done in the
It's
chapter
'cause-
so far.
Why
It's
did
because
you
you're
add an extra
multiplying
step of
this
dividing
by
it by
A
two?
and then getting the determinant of it.
Instead of multiplying by 1/2, you divide it by 2.
What do you
That's
do?
a lot.
She put
You can
0.5 times A, the determinant of 0.5 times A.
How do you even manage?
That's what.
What?
You should just do it in 2
Find the
steps.
detriment of 0.5 times A.
Okay.
It's
You know-
determinant, not detriment.
Detriment.
You know what
The detriment.
I don't know.
Okay, I actually understand this.
I like these because
Oh. Okay. Okay.
All right, we have two options. There's like two Cramers rule problems that I'm gonna do. We can either do them now or we can wait and do those on Monday, and you can start this stuff now.
We can do this now and wait
Do
till
it
Monday.
Monday.
Do it Monday.
And
Do it
start
Monday.
this.
Which one
Start
we
this now?
work on
Okay.
Monday?
Huh?
Which one we work on Monday?
But I want to finish this.
Yeah,
so
I
don't
wanna
have
do the-
to-
But Cramers rule uses this, so if you like, I want to make sure you understand this. That's also why. But you still will have a ton of time on Monday. You still don't need to do this for homework. Okay. I have to see where. Okay. All right. Again, we're gonna have a by hand section and a calculator section. So by hand, 3, 9, 11, 15, and 29. But you don't know how to do that yet, so don't do that one yet.
I need a paper.
Then calculator. I want you to check the 3x3s that you did, which is going to be number 11 and number 15. So you can, as you do 11 and 15, you can just show that you checked it on the calculator. And then number 23, which is a triangle problem that we just did. So that's going to be basically all of it for what we're doing. Because we will only do Cramer's rule for 2x2s.
Let's see if I can like do this.
No.
So the only one you can't do yet is 29. So again, not homework, but and you'll need 3.8 notes for Tuesday, which you, if you finish this, will have time to do on Monday. So.